Building structures should be designed to be reliable and safe throughout their lifetime. To meet these requirements, engineers need support in the design process, standards that provide procedure and rules for the design of structures. In the case of glass structures, the European standard EN 16612 is available today. EN 16612 deals with the durability of infill panels made of monolithic glass, laminated glass, or insulated glass units, which nowadays are mainly used as windows and facades. The standard is only valid for infill panels simply supported linearly around the edges, loaded with a uniform load perpendicular to the surface, which can be classified in the class consequences lower than CC1. The load thus mainly includes wind, thermal stress, and the load specific to the insulated glass units, temperature, altitude, atmospheric pressure. The definition of infill panels, which can be designed according to EN 16612, is usually given in the national annex. The design of structural glass elements corresponding to the class consequences CC1 and higher should follow the provisions in EN 19100. Structures are designed according to limit states. The limit state describes the state of the structure beyond which the criteria of the state are no longer satisfied. A distinction is made between the ultimate limit states, where the stability, strength, brittle fracture, and other factors indicating collapse of the structure are examined, and the serviceability limit state, where deformation or vibration are checked. Exceeding the limits of the serviceability limit states does not lead to collapse, but performance of the structures is affected. Modern standards for the design of building structures are based on the partial safety factors method. Its advantage is the simplicity. In the method, the variables decisive for the safety and serviceability of the structure are introduced into the calculation by the so-called design values. The design values are determined from the characteristic values using the corresponding partial safety factors. The factors are bigger than 1. Thus, in general, on the load side, the design value is obtained by multiplying the characteristic values by the partial safety factor gamma f, while the design strength is obtained by dividing the characteristic value by the partial safety factor of material gamma m. In the ultimate limit states, it must be proved the largest design load effect that occurs with given probability is less than the smallest design capacity of the structure element, which is expected with the required probability. The provisions of EN 1990 and EN 1991 may be used to determine the loads and their combinations. The infill panels should be designed as below. In the ultimate limit state, the design value of the tensile stress resulting from the loads imposed on the glass panel is compared to the design tensile strength of the glass according to the equation. In the serviceability limit state, the maximum deformation should meet the criteria given by this equation. It should be noted the partial safety factors for the load action gamma f for infill panels, which fits into the class consequences lower than CC1, are lower than those used for structure of class consequences CC1 or higher. Design value of the bending strength of any yield class is determined from the characteristic value according to this equation. FGK is a characteristic value of the bending strength of any lead class for soda lime silicate float is equal to 45 megapascals. K-mod is a factor for the load duration, reaching values from 1 for loads with a very short duration, for example wind gust, down to the smallest value of 0.29 for the permanent load such as self-weight. It significantly affects the values of the design bending strength of glass. For determination it is possible to use this equation. Ke is a factor for edge strength, taking usual value Ka equal to 1 in case of simply supported glass panes along 4 sides and lower than 1 in other cases. Ksp is glass surface profile factor. For the float glass, Ksp is equal to 1. For pattern glass, Ksp is equal to 0.75. This factor varies depending on the glass material such as drawn sheet glass, enameled pattern polished white glass or sandblasted glass. See in the Eurocode EN 16612. Design value of the bending strength of pre-stressed glass should be determined using this equation. First part of this equation is the design value of the bending strength of float glass itself. The second part represents the increase in strength due to the thermal or chemical treatments. FBK is a characteristic value of the bending strength for pre-stressed glass, doesn't depend on the chemical composition. For float or drawn sheet glass and so on, see EN 16612. Strengthening factor Ky depends on the manufacturing process. For horizontal toughening, Ky is equal to 1. European standard EN 16612 provides guidance on the basic principles for the design of glass panels loaded perpendicularly to the surface. In addition to the type of glass, the design strength of the glass is significantly influenced by the load duration and surface profile of the glass, as shown in the summary table. The lowest design strength values result from permanent loads.